Okay, so LiquidStack, you fairly recently unveiled your GigaModular CDU solution. I think that was at the recent Data Cloud event. And I guess it'd just be good before we, find out a bit more about it, just be good to understand how you arrived, at the point where you've, unveiled this solution.
Yeah, thank you, Philip. Well, it was definitely an evolution, I think, in our roadmap. And when we launched our 1 megawatt CDU late last year, we knew that the capacity of CDUs was likely to increase, and a lot of this was being driven by the announcements coming from NVIDIA and other chip manufacturers about roadmap announcements and rack density projections. And so we were looking at iterating our product portfolio with a larger scale, larger capacity CDU, and recognized that one of the big challenges is future-proofing your data center design and really having a solution for direct-to-chip liquid cooling that sort of grows with your facility and the demands for AI implementation, which are highly variable. So we decided to develop GigaModular as a platform, not as a product, and really give customers more flexibility and adaptability in how they deploy liquid cooling for AI.
Okay, and I guess everyone knows that AI is driving the data center industry, and liquid cooling market is sort of come alive as a result, I guess. Although there are different technologies, so I don't know whether you have any thoughts as to how, from the direct to chip to full immersion, I guess, just your thoughts as to the suitability of those depending on, what environment you have. I guess obviously the server manufacturers have a critical role to play as well.
Yeah, for sure. I mean, I think from a LiquidStack perspective, we're a full service liquid cooling company. So we provide solutions and services for all three modalities of liquid cooling, which include two-phase immersion, single-phase immersion, and also single-phase direct-to-chip. And at the moment, you're correct in saying that a lot of the scale-up is happening around single-phase direct-to-chip. And I think this modality has been around for a while. I think it dates back to maybe the mainframe days when IBM started using liquid cooling in mainframes and mid-range computer systems. So it's fairly well understood, and it's easily integrated more or less by the hardware manufacturers and integrators that are providing the kit around AI deployments. I think that as things evolve, we expect to see chip TDPs, total dissipated power, continue to increase. And with the increasing levels of TDP, that means that single phase solutions may have some practical limitations and challenges around the amounts of heat that they can actually reject from the surface of these GPUs and ASICs. So with the increasing TDPs, we would expect to see more applications for two-phase variants, whether it be immersion or direct-to-chip. And certainly in the future, there's the potential for the hybridization of different liquid cooling technologies. In summary, we like our position as a company mainly because we do offer all modalities of liquid cooling, so we're really agnostic to the different approaches.
Yeah, I guess that, I mean, from my knowledge, that makes you fair. Can you be fairly unique? You're unique, because as you say, most people have a particular solution that they're promoting, but you offer those. But in terms of what we're talking about today, the new platform, I think you describe your direct-to-chip cooling solution as without traditional limits or boundaries, which is a big sort of bold statement. So how do you sort of fill out that statement? What is it that you're doing that justifies that, if you like?
Sure. Well, I think first of all, the infrastructure that supports direct-to-chip liquid cooling can be located in a lot of different areas within the data center. So for example, it can be located within the row. They can be located within the perimeter location of the white space, or sometimes in a mechanical corridor, which is an adjacency to the white space. And the idea behind GigaModular was to build it in a platform which allows the flexibility for it to be located in any of those three traditional or non-traditional locations. And then also to basically design it in such a way that it's constructed with 2 megawatt nominal capacity building blocks. So the unit can start out on day one as a 2 megawatt CDU, but grow into a 10 megawatt CDU, which can then also be linked in parallel with other GigaModular systems on the same loop. So essentially, allowing I would call it like a pay-as-you-go or a pay-as-you-grow approach to how the infrastructure is deployed to support and facilitate direct-to-chip liquid cooling. And then I think the other aspect is trying to reduce a lot of components or material that is redundant. If you go with a what I would call a monolithic CDU approach, where you're just basically taking CDUs and piping them onto the same distribution loop. And what happens is you have a lot of unneeded redundancy in pumps and controls and other materials, which contributes to both direct and indirect carbon footprint. So the idea behind GigaModular is obviously this modular, scalable, pay-as-you-grow platform, but also the ambition and actuality of reducing the carbon footprint around how we manufacture and ship the product.
Okay, so yeah, I mean, following on from that, it'd be good to understand what are the key, key features, components of the solution. How has it been put together?
Right. So basically, the GigaModular is comprised of first of all, a control module. So this is essentially the brain of the system, and it controls all of the different actions and tasks of the CDU to control very precisely temperature, pressure, and flow. And then you have additional what we call pumping modules, which are part of the platform. So the pumping modules help build the unit from, let's say, a 2 megawatt system on upwards to a 10 megawatt system. And then you can also add additional pumping modules depending upon the level of redundancy that you want in the system. So for example, some customers may want to operate it at an N level of redundancy. Others may want N+1 or N+2. And that allows concurrent maintainability of the system depending upon what level of resiliency and redundancy that you want.
Okay, and in terms of the scalability, I mean, as we know, the server folks are talking about, crazy sort of megawatts per rack even, or whatever, some stage in the future. Is this platform, I suspect I know the answer, but because you said about future proofing, but is it basically able to scale to meet, if you like, known or expected, power densities well into the future?
Well, I think publicly, NVIDIA has announced that in the future, their systems will reach 600 kilowatts in total rack density. And it's our belief that the rack density will continue to increase and approach 1 megawatt or up to 1 megawatt in the future. Not all racks will be 1 megawatt for sure, but definitely some that are fully loaded will reach that level of power threshold in heat density or heat load. So with the advent of 1 megawatt racks coming in the future, we like the adaptability of GigaModular to help serve those types of really high density heat loads, and it can certainly support that level of heat rejection capacity. Just to reiterate, the GigaModular can reach 10 megawatts in total heat rejection capacity, but can also be linked in parallel with other units to go to say 20, 30, or 40 megawatts in total heat rejection capacity. So it's what I call virtually limitless, but there's always obviously some limitations based on things like pipe sizing and pipe distribution networks.
And I guess it'd be good to understand. I mean, you've launched the platform fairly recently, but have you had? I guess you were working with partners, to develop it, but also since you've announced it, what's been the overall feedback for GigaModular, the CDU, the platform?
Well, the feedback's been amazing. The announcement that we did in Cannes at Data Center World Congress was super well received. We had a lot of focus and attention from hyperscalers that visited us at the show, as well as large and medium-sized co-location companies. And I think more recently, the platform has gotten some attention from our competitors, which means that they must be a bit nervous. Which we think is a good thing.
Okay, and to be fair, you sort of earlier on you talked through the sort of flavors of liquid cooling, if you like, but just be good to have your thoughts. I mean, clearly air, is the incumbent. People understand that liquid cooling is required for the higher and higher densities, and then there are different. Do you have any thought? I mean, are we talking a sort of multiple hybrid cooling future? Because I think you mentioned, potentially people will use more than one different liquid cooling solution, and I guess air has its place. So is what would be your sort of vision or thoughts as to where this might end up at some stage?
I think that there's definitely the potential to mix single phase and two phase technologies together. An example could be leveraging two phase immersion liquid cooling with single phase direct to chip liquid cooling, or hybridizing two phase direct to chip liquid cooling with single phase immersion, just as an example. So I think bringing these different modalities together provides the opportunity to mitigate the use of air cooling for really, really high density heat loads that we're seeing from AI. And I think AI is very unique also because of the type of throttling that we see in the application workloads, right? And in what AI is not a highly predictable workload, unlike some other workloads that we see in more traditional or legacy data centers. So the liquid cooling approaches have to react quickly and immediately to these varying changes in workload, whether they're throttling up or throttling down.
Yeah, actually, that's an interesting point because I'm reading something yesterday but I think bursting, was described as that. So, how much of a challenge is that you're sort of, you're going along at a fairly steady level, and then suddenly there's some huge, and obviously with the scale of the AI, it's not like a little spike; it's a potentially a huge spike. Is that a particular challenge for folks like yourself to address?
It really is, and it's a good thing actually in a way. I mean, one of the deployments that we're doing right now is for a chip manufacturer that has a very unique workload and requirements around the flow rate in the TCS loop in the data center. So, we've been doing a lot of tuning of our PID loops to facilitate the specific flow rate that they need to accomplish their workload and their mission. And that's where services become really important because whilst we'd all like to ship and deploy standard solutions, many times we have to do some level of customization either in the factory or in the field. And that adaptability is part of what also makes LiquidStack pretty unique.
Yeah, and then just in terms of the sort of roadmap for the company, you've clearly just launched the platform, so I guess you have some idea as to how you're going to develop that. Is that the main focus, raising the profile of the company, other technology? Would just give us a flavor of what you're happy to share in terms of your direction of travel, if you like.
Sure, sure. So we just announced a new facility in the Dallas-Fort Worth Metroplex. It's just a few blocks away from our first factory there. So we're putting a lot of focus on scaling up our physical operations and manufacturing capacity. And then we're also undertaking two additional parallel work efforts around expanding our capacity overseas. So more to come on that as far as our overseas manufacturing expansion. As far as the roadmap is concerned, we're continuing to spend a significant amount of resource on R&D, and we have a R&D team both in the US as well as in Hong Kong. And those teams are working on some roadmap activities that are, really looking more at the future of liquid cooling and specifically how these higher TDP chips can be cooled, using liquid, whether it be with single phase or two phase platforms. A lot of the work that we're doing right now also involves academia. So we're working with the University of Texas Arlington in the Dallas-Fort Worth Metroplex, and then also other universities globally.
Okay, I mean, it's been great to chat, and it's fascinating to see what it is you're doing with this platform, and the different approach you're taking. It sounds exciting, and I'm sure we will talk again as and when other things happen. But at least, Joe, for now, appreciate the time because I know you're traveling and busy. But thanks for the time you've given me. Enjoyed it. Thank you.
Appreciate the opportunity, Philip. Thank you so much.